Welcome all of you to this new video of Paul's 10th board maths for ICSE. Okay, now here in this video we are going to take circle properties, 5 most expected questions, as you can see. So just listen to it carefully, and these sums might not come for the exam, but something like this, something of this type might come for the exams. Okay, so let's quickly see. Now here, before we start with circles properties, what are the properties of circles? A quick recap of that. If we have a circle, then if this is the diameter, then any angle in the circumference that it makes on the circumference is always 90 degree. Here, see, all these angles are 90 degree as long as it is angle in a semicircle. Okay, so all these angles, I can make any number of angles, all will be 90 degree. Okay, that is one of the theorems that we are working on, so we'll be using this again and again. So if you have forgotten, I thought I'll give you a recap of this. And then we have the next one is, if you have a circle here, and in this circle this is the center. Okay, supposing this is the chord, this is the minor segment, this portion is the major, this is the angle subtended at the center. Okay, angle that the chord is holding up at the center, let this be 30 degree. Then the same chord, if it subtends an angle at the circumference, then it is a 15 degree, that is half of it. Okay, if this is 120, this is going to be 15. Similarly, any other angle, all these, as long as these are the two end points of the chord, and this chord is holding up this angle, this angle, this angle, all at the circumference, and the 30 degree at the center. It is called subtending angle. All these are half of the angle at the center. Okay, so angle at the circumference is equal to half of the angle at the, so angle at the circumference is half the angle at the center. Another thing, if we have a segment minor and major, angles in the same segment, see, all these are angles in the same segment, all these are equal in value, even in the minor segment. Okay, so these are few of the concepts that we are going to use today, okay, in this chapter. So here this question says, we have a circle here, we have a chord BC, we have to find angle BDC. B, first things to locate, BDC is here, BEC is here, and BAC, it is here. So we have to find this, this and this. Okay, what they have given us is this 58 degree. Okay, now one thing is they have also marked this BD. Okay, BD is the diameter. Okay, that also they have told us. BD is the diameter. It is very important to locate the diameter. So immediately what happens? Angle DCB is equal to 90 degree. Angle DCB is equal to 90 degree. Angle BDC is equal to 90 minus 58. Okay, why? Because total is 180. This plus this plus this is the 180. This is 90. So this one is another 90 minus 58, which is equal to 32 degrees. So first answer is got. BDC is a 32 degrees. BEC is now how much? Now if you can see, BDCE is a cyclic quadrilateral, and opposite angles of a cyclic quadrilateral are supplementary. So angle BEC, we can find it by other methods, but this is the simplest and the fastest. So 180 minus 132, because this plus this, these are opposite angles, these two will add up to 180, that is here to here. Okay, not only 58, and this one plus angle D plus angle E will be equal to 180. So what you have to write is 180 minus 32, and that is equal to how much? That is equal to 148 degrees. So we got this angle also. So what we have to write here is, you can give the reason as opposite angles of cyclic quad. If you just write this much, this is good enough. Okay, opposite angles of a cyclic quadrilateral. BAC, angle BAC is a 32 degrees. Okay, angle BAC is a 32 degrees. So this is 32 degree, which means that angles in the same segment are equal. Angles in the same segment. You can just write this much. Okay, if you just write this much, angles in the same segment. Why? BC is holding up B also, BC is holding up A also. Therefore, angles in the same segment. For BDC, you can actually write triangle sum property. Okay, so you can say triangle sum property, but before that you should show this calculation. Okay, so here when you say angle DCB is equal to 90 degree, you can also say angle in a semicircle. Okay, now here is a question which says this is a pentagon, as you can see, not a regular pentagon. Okay, so this is not a regular pentagon. 1 2 3 4 5, and AC is the diameter they have told, and ACB, you have to find angle ACB. This angle, let me mark them, EDC, EDC is this angle, and BEC is this angle. Okay, and BEC is this angle. Okay, so you have to find this angle BEC. I can see very clearly in the beginning only. Say this is equal to 50 degree, angles in the same segment. Okay, that I can see clearly. Clearly BC is holding up 50 degree and this, because they have given this as 50. Okay, now we want angle ACB, this angle. Now remember, if AC is the diameter, then this angle is a 90. Therefore, angle ABC is equal to 90 degree. Angle ABC is 90. Why? Angle in a semicircle. If you give these reasons, then your examiner will be very happy. You must give. And angle, therefore angle ACB is 90 minus 50, which is 40 degree. Here you can write triangle sum property, that is sum of all the angles of a triangle is 180. So you get this as 40. Let me write this also as 40. Now we got angle ACB, we got. So we got this already, EDC, EDC. Now if you see another thing, that these two lines are parallel. Okay, they have given EA is parallel to BC. If EA is parallel to BC, then this angle is a 40 degree. Okay, alternate angles makes a 40 degree. Okay, alternate angle is a 40. Now do you see this cyclic quadrilateral EDCA? Okay, little difficult to understand sometimes, but then once we got this as 40, this one and this one are opposite angles of a cyclic quadrilateral, and so the value of this is a 140. I'll also tell you how to write it. So here we need angle EDC, finding EDC. How to find EDC? So in order to find EDC, first we will say angle EAC is equal to 40 degree. Why it is 40? You can say EA is parallel to BC. Another thing I want to say, whatever is given, please make good use of that. If any of the given things are not used, then your sum, 90% probability is there that your sum is going wrong. Okay, so if I am not using this parallel lines, maybe I am taking a very long method or I am going wrong. So always use the given things and your sum will go easily. EAC is a 40 degree. Therefore, angle EDC is 180 minus 40, which is equal to 140 degree. What reason do you write? You have to write ACDE. ACDE is a cyclic quadrilateral. Minimum you write this. If you have time, you can write more opposite angles of a cyclic quadrilateral and all that. But then if you don't have the time, if you just indicate this much, it shows that you have understood the chapter. Now, here in this question, they have asked us to find these three angles, and they have also given AC is equal to BD. AC and BD, these two things are equal. Now, O is the center. Now, always look for this thing, whether they have told O is the center or not, whether they have told AB is the diameter or not, because what happens is, generally, if you just see a line passing through this, through the circle, okay, you just tend to take it as the diameter even if they have not mentioned. So if unless they tell you O is the center and this AB therefore is passing through O, you can't take it as the diameter just because it is a big line and it is passing it looks to you like through the center of the circle. Okay, so don't do that. So here angle ABC, let me see where is angle ABC. Here this angle they want, BAD, BAD. Now they want this angle. It's very important to mark first ABD, ABD. Okay, so ABD is this angle. So they want us to find these three angles. First thing, if this is the diameter, then these two angles are 90 degree. So angle ACB is equal to 90. This is for angle in a semicircle. Angle ADB is also equal to 90 degrees. These two things we know, these two are 90. Now, if this angle is a 72, then in triangle AOC, you can say OC and OA are equal. Therefore, angle OCA is equal to 180 minus 72, that is 108 divided by 2, which is a 54 degree. If this is a 54, this much is a 54, then this is 90 minus 54, which is angle OCB is 90 minus 54, and that is equal to 36 degrees. Okay, so this angle becomes a 36. This is a 54 degree. Okay, what do they want? They want angle ABC. They want this small angle. Okay, so if this full angle is a 54, okay, here this full thing is a 90, then this one is how much? Okay, so angle ABC is 90 minus 54, which is equal to 36 degrees. So we get the first answer is a 36 degree. Now BAO is how much? BAD, not BAO, BAD is the small angle over here. How much is that angle? Okay, so here we will be using another theorem. This chord and this chord, these two chords AC and BD are equal chords. Therefore, they will subtend equal angles in the same circle. So this chord AC has upheld how much? ABC, that is a 36 degree. Okay, it has subtended 36. So DB will also subtend 36 degree. Therefore, angle BAD is equal to 36 degree. Okay, angle BAD is equal to you can actually directly write 36 degree. Give the reason: equal chords subtend equal angles. Okay, equal chords subtend equal angles. Just say this much. Okay, now the next thing is angle BAD. Now the next one is angle ABD. That is this big angle we have to find. Okay, if this is a 36, this small one is a 36, here this one is a 90, therefore angle ABD is equal to 90 minus 36. Okay, 90 minus 36, triangle sum property, which is a 54 degrees. Okay, So what was difficult in this question was this chord property. Angles, equal chords will always subtend equal angles at the circumference if the circle is same. In different circles, it's a different thing. Okay. These sums are from R.S. Agarwal. This is from chapter 18, circle properties, and this sum is also a PYQ. This is a previous year question. This is a 2022 question. Okay. Now this angle is given to as a 62 degree, and you have to find center is O. Okay. So center lies here, and you have to find angle ADC and angle CAB. Find angle ADC and angle CAB. ADC, this angle. Now these are angles in the same segment. That is, if I join this, these are angles in the same segment. So this is also 62 degree. Angle ADC is equal to 62 angles in the same segment. Okay, angles in the same segment. And the other one, angle CAB is equal to angle CAB. This angle is going to be, if this is the diameter, AB is the diameter, this full thing is a 90. I have already joined it. This full thing is a 90. So CAB. So here in this question, you are, so angle CAB, this is how much? That is 90 minus 62. Okay, you can say triangle sum property. So is equal to 28 degrees. So this is 28 degrees. This was a small question. Now here is a circle, center is O, and we have one line passing the diameter going and ending there. PQ is a chord which is extended and it meets at R. Now the question is find X. What is X? So X is an angle here. How do we find this angle? So now this is the sum where we have TS as the diameter which is extended till R, and PQ is a chord which is extended and meets at R. This angle is a 20 degree. What is given to us is QR is equal to OP. QR is here and OP is here. These two are equal. But we also know another thing. OP is equal to OQ. Okay. And OP is equal to QR. Therefore, OQ is equal to QR. Okay. OQ is equal to QR. So, triangle OQR becomes an isosceles triangle. Therefore, angle ROQ is a 20 degree. So they didn't ask for X. We just got this as a, they didn't ask for this angle. So it's just a 20 degree. Now we know. Okay. If this is a 20 degree and then these two are equal. Okay. And how much is this angle then? Angle OQR is equal to, this is 180 minus 40, which is 140 degree. So we know this also 140. Then this is 40 degree. Okay. So angle OQP is equal to 40. That is angle in the same straight line. Angle OPQ will also be equal to 40 because these two are equal. It forms isosceles triangle. Okay. You can write reason. Okay. So we know this is also 40 now. How much is this angle then? Now this angle becomes 100 degree. Angle POQ is a 100 degree. Okay, because of triangle sum property. If this is 100, this is 20, 120 over, then X is equal to, so angle X is equal to 180 minus 100 minus 20, which is 60 degree. That is the angle in the same straight line. So maybe this can be done by other methods, but this is one method I found very much suitable, so I did it. Okay, so this was PYQ 2018, also from R.S. Agarwal. These sums I am doing from R.S. Agarwal chapter 18, circle properties. Okay, so these were few of the most expected questions, and I felt these are little important. The concept behind it, especially this, where they have used the radius like that. that I found these concepts little important. After this, my next video is going to be tangent and its properties. All properties of tangent we are going to use in it, and we should not miss a single question from geometry, from trigonometric identities. I have uploaded it previously, so we should not miss a single question from these chapters in the exam. They are actually very easy ones. People tend to leave out circles. That is why I am making the videos 5 most expected questions. Okay, after this 5 more expected questions of tangent and its properties is going to come up very soon. Okay, thanks all of you. If you have not subscribed, do not forget to subscribe. Once again I am telling you, and also leave a comment behind. Let me know which is the very next chapter, which chapter you are finding difficulty in. I shall be doing that chapter first and uploading a video. Thanks all of you. Bye then.